Hello, physics students. Before we get into talking about the center of mass, I want to start the video with a quick demonstration. Now, one of the first things we have to do when we're born is learn how to walk on 2 feet, since, annoyingly, we're bipeds. And that process doesn't happen instantaneous because we have to learn how to balance. Now, if you've ever tried to, say, balance a pencil on the tip of your finger, you know that if I place the finger at any arbitrary location, the pencil will rotate off my finger and it falls down. Now, that rotation is due to the forces on the pencil creating what we call a torque. And torque changes rotation. Now, however, if I balance the pencil at a precise location, I can balance it on my fingertip and it doesn't rotate off. Why? Now, that location that I marked with a little black mark on this pencil is known as the center of mass. The center of mass is the point of an object where gravity seems to act. Now, sometimes it's predictable. In a uniform object, the center of mass will be usually somewhere located in the center. Whereas sometimes it's not so predictable. Here I have this plastic bird toy, and you might think the center of mass would be under its body. And if I place my finger under the body, you will see that the bird does not stay on my finger. However, if I place the beak of the bird on my fingertip, you'll see that it balances quite easily. So, let's explore working with the center of mass. Let's talk about the center of mass, and then we'll talk about how to calculate the center of mass. Now, the center of mass is an important point in physics. It's the point of an object where the force of gravity seems to act. Typically, we mark the center of mass with an X. So here, it is on this pencil. Now, for a uniform object, and by uniform we mean a simple shape and a uniform density throughout, then the center of mass, as you would expect, is most often in the center of the object. But that's not true for more complicated shapes. Now, the center of mass is important because how the forces are acting on an object in relationship to both the center of mass and the point that the object is supported, or often called a pivot point or a fulcrum, will determine how the object rotates. So in this first picture, I am supporting the pencil at the center of mass. So a couple of other points that are important to note. The point that I am supporting it here, this is often called a pivot point, sometimes referred to as a fulcrum. Now, if I label the forces acting on the pencil, my finger is pushing up on the pencil, so there is a normal force here. And of course, coming down, the force of gravity seems to act at the center of mass. And so I have that the force of gravity, which would be equal to mg. So both the normal force, the path of the normal force, and the path of the weight pass through that pivot point. Because of that, there will be no rotation of the pencil. But now let's look at what happens when the center of mass and the forces are not applied at the pivot point. So again, over on this picture here, my finger is now supporting the pencil there. So that is the location of my pivot point. Now let's label the forces acting on the pencil. Well, the normal force is still coming from the location where my finger is pushing up on the pencil. So here is the normal force here. But the weight force now is applied at the center of mass. And you see that the normal force is no longer in a position to be directly over the weight. Now, translationally wise, there will be still no up and down acceleration. So if I look at translation motion, or some books would just say looking at the linear motion, well, I still have Newton's second law, and I would still have here that Fn minus mg is adding up to 0 still. I will have no acceleration up and down in the y direction. Now, however, I do have a rotation because we'll see later on in the course that this force, when I take into account the distance from the pivot point, I am producing what's known as a torque. Torque is given a symbol, a curly d, and the size of the torque will be equal to the force times the perpendicular distance, or in this case, it would be equal to mg times whatever that perpendicular distance is. Now, we'll talk about torque a lot more later on in the course, but all you need to note right now is if there is an unbalanced torque, then you will have a rotation. Torque creates rotation. Just as unbalanced forces cause linear motion or translation to happen, unbalanced torque produces a rotation. Now, the normal force is producing no torque because the perpendicular distance for the normal force from the pivot point is 0. And so there's no torque due to the normal force, but the weight produces a torque. Now, like I said, torque is a very powerful tool in physics. More on that later. But because how the forces applied to the center of mass will determine whether or not you have a torque or not after an object, working with the center of mass is an important concept. So